I am here at the University of Sydney where the mechanical engineering shop has built this incredible piece of apparatus for me. It is a 40-pound, that is 19-kilogram flywheel on the end of a meter-long shaft. Can you imagine trying to hold this out horizontally with just one hand at this end? It is impossible, okay? Now I'm going to let go. You going to be able to hold this at all?
I hope so.
Can you lift it out? Make it horizontal. Hold it, hold it, hold it. Come on, just try to. I want you to hold it out horizontal. See if you can. Hold it, hold it. Oh, come on. No. What I'm going to do is I'm going to spin this up to a few thousand RPM, and then I'm going to attempt just that, to hold it from one end and have it out horizontally. Five, four, three, two, one, boom. I'm going to let go with my left hand. What you'll see is that the shaft remains horizontal. You can see it going around there.
It almost looks as though the wheel is weightless. How does this work? Well, instead of pulling the wheel down to the ground as you'd expect, the weight of the wheel creates a torque which pushes it around in a circle. You may recognize this as gyroscopic precession. For a more detailed explanation, click the annotation or the link in the description to see my video on the topic. Here, I want to try something more extreme.
I'm going to try to lift it over my head with one hand while it's spinning. Wish me luck.
But before I make the attempt, Rod wisely suggests that I first check if I can lift the wheel above my head without it spinning.
Let's prove that I can lift it just this end without it spinning. Here we go. I mean, it's just kind of awkward with the hand.
Careful. Careful.
Woo! Just barely. Oh, goodness. Do you even lift? Clearly I do not.
Undaunted by my lack of strength, I'm going for it. But I want to make sure that the wheel is spinning as fast as possible to give me the best chance of success.
Give it 10 more seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, go! That was perfect. Now I'm going to release my left hand, and holding only with my right hand at the end of the shaft, I'll try to lift it up over my head. This is a 40-pound, 19-kilogram flywheel. Ready? Here we go. 3, 2, 1. Beautiful. Let's go again. In 3, 2, 1. Nice. Smooth. 3, 2, 1. It feels incredibly light as I do that.
When you said it felt incredibly light,
yeah.
You know, when you're lifting it feels light?
Yeah.
Shouldn't.
I know. Honestly, I have lifted it up with one hand when it's not spinning.
Yeah.
And it feels really hard to lift it up, like it's a big effort.
Yeah.
But with this, when it's spinning, it honestly felt like it was just...
wanting to go up by itself.
Yes. It felt like I was not struggling, like I was not putting in the amount of force that you think to lift that kind of weight.
I bet if you let it go, it'd crash down to the ground. That's not weightless.
We can't do that, though. We can't do that part of the experiment. What we could maybe do is I could stand on a scale, and we could see what the weight of me plus that apparatus does while I'm lifting it up over my head. See if I get lighter, in essence. You can see that just my weight is about 72 kilograms. Now when I pick up the flywheel, it goes up to about 91 kilograms. which makes sense because the flywheel itself is about 19 kilos. That's 42 pounds. Now we're going to spin it up, and I want you to make a prediction. As I'm lifting it over my head, do you think the scale reading will be more, less than, or equal to 91 kilograms? What do you think? You can make your prediction by clicking on one of the on-screen annotations, or if you're on mobile, you can click a link in the description. 5, 4, 3, 2, 1.